Okay, we want to talk about factoring. So what we're doing is we're picking up those prerequisite chapters. You know, the 0.2 was multiplying polynomials together, and we were doing mostly a binomial times a binomial. But you'll see on that special worksheet you got that there were some other examples. And today we also want to talk about factoring, though, which is really 0.3, does a very basic introduction of factoring. So let's start with that. And the first thing you always want to remember when you're talking about factoring, of course, is GCF. So this, of course, is when we're talking about anything that has a common factor to all the terms. So if you're looking at x squared plus 3x, then of course those are two terms. Okay, we want to make sure we're using the right words because the terms are separated by addition in this case. Could have been subtraction, would also make two terms. And both of those terms have an x. So we're going to factor out the x. That means it goes in the front because I choose to put it in the front. And it multiplies by a parentheses for what's left behind. And what's left behind in this first term is just an x, of course. And you still have plus what's left behind in the second term, the 3. So always remember to look for the greatest common factor whenever you have it. Okay, then we can talk about factoring those special products. We talked about them when we were multiplying things together. And remember, all we're doing when we're factoring is kind of going in reverse of multiplication. So factoring is almost like dividing too. You're dividing them into two parts. Okay? So one of the things we had talked about was difference of squares. And that's when you have something like x squared is certainly a perfect square. And it's a difference of squares, so we have that minus sign. And then you have another perfect square, so we'll use 9 in this case. And you'll recognize that as a difference of squares, which comes from conjugates. So we would factor this to different factors, right? Because factors are divided by multiplication here. So those two parentheses are being multiplied together. In the first one, x plus 3, and in the second one, x minus 3. And you'll remember, this is called a conjugate because it is a binomial, means two terms, where the middle sign has changed. And when that happens, then of course those inner and outer terms will cancel. So, brings up the point that every time you factor, you should always check yourself. I don't often give answer keys for factoring because you can check yourself quite easily and you must check yourself. So this will be the check. Okay. This had been my answer to factor. If I wanted to factor this, then this is my answer. But now I'm going to check my work by multiplying it and seeing if I get back to what I'd started with. So remember, I would do the repeated distribution. I'm going to show you the arrows so you can follow along, but you will try not to draw arrows. You'll try to do this in your head. So the x times the x, distributing to both terms, minus 3x, and then you have this plus 3 gets distributed to the first x, and then that same 3 gets distributed to the other 3. Oops, and makes minus 9. And of course, this is where you see how those outer and inner terms will cancel. Okay? And you're left with, of course, the x squared minus 9. So check mark, because I did indeed come up with exactly what I had started with. So I factored it, okay, and I then multiplied them together to make sure I got back. So it's interesting to note what I started with was two terms. Here I am, stuck on this vocabulary. When you start with terms, the directions will be to factor it. Your answer will be in factors, okay? This one we want to look at that other special product, okay? When you multiply a perfect squared binomial. So let me start with the terms and we'll have to factor it. So let me write something like x squared plus we go 10x plus 25. And I like the number 25 because it just jumps out at you that, hey, that's a perfect square there on the end. That's a perfect square, of course, here at the beginning. And then I have to wonder about the middle. Is the middle the result of a perfect square trinomial? So I'm thinking, okay, a lot of factoring is guessing, okay? So I'm sort of thinking in my mind, I want to guess that this might be x plus 5 times the exact same thing, okay? So of course, in this case, if I want to check it to see, I know I'm going to get the x squared, and I know I'm going to get the 25. I've set it up that way. I chose the x for that. I chose the 5s for that. But the question is, did I get the middle term right? Okay, that's going to be the key for us when we're factoring, is choosing the values to get the end numbers, or the end values here, the x squared and the 25, and then checking to see if we can get the middle. Remember, the ends are made by multiplication, but the middle is made by adding together. So that's a little trickier. So here I have, this makes 5x, this also makes 5x, and together they make the 10x. So I did manage, my guess was right, this was a perfect square trinomial, so this is my answer. Okay, so maybe I'm belaboring a little bit, because I think you're probably going to be pretty good at this, but of course we're going to make it harder, and I want to make sure we have the language. Now we have to talk about those cases that just aren't so special, okay? And we don't have a name for them. You know, they're not the difference of squares, they're not a perfect square trinomial, just random sort of binomials multiplied together. And how do you go about this? And my answer is going to be guess and test. Okay, you might not like the name of it, you might not like the idea of it, but in the end it will serve you well, okay, because you're going to get good at it, as opposed to relying on some memory trick that doesn't, it's going to take you time, it doesn't always work, blah, blah, blah. So let's just try one. Let's say I put something up here. X squared plus 6x plus 8. Alright, and I want, the directions of course would be to factor this. I'm factoring this because right now it has 3 terms, and I would prefer this expression to be a list of factors rather than terms. So I don't know what to do. Okay, so I'm going to start by saying I'm going to try to factor this into 2 factors, and I'll start with whichever one is more obvious. Okay, so I'm going to start with this one. I know I have to make the x squared through multiplication, so I'm left with x and x. Then you look at the other one and you say, go to the other end, okay, the less obvious end, left or right, whichever one you didn't start with, and you know you have to get through multiplication. The problem is 8 has a couple of choices. I could do 1 and 8, I could do 2 and 4, and you don't know which one to do. So you're just going to imagine guessing, okay, and say you put a 1 and an 8. And then you have to test and see, do I come up with the proper middle term here, okay? And how do you get the middle term? Remember, the middle term comes from these numbers added to these numbers. And so you'll see that adds up to 9x. So that's not what we wanted, so that's not going to work. So, okay, let's erase that. I'm going to wish I had a bigger eraser. Alright. There goes the 1 and there goes the 8. What's the other way to make an 8? Of course, is 2 and 4. And I know you were there well before I was. 2 and 4, of course, makes the 8. That's why I chose 2 and 4. And just checking, I have 2x and a 4x makes a total of 6x. So I did get it, okay? Notice, you know, I'm not listing all the factors of this, and I'm not listing all the factors of this. And I'm just testing. The only thing you really have to test is these middle numbers, okay? Because these ones will work out You're not even going to try anything that doesn't make these the end numbers work. Okay, so of course things are going to get a lot harder than this, and we'll do a lot of practice with it. But I want to talk about one thing that seems to trip a lot of us up even when it shouldn't, okay, and that's when this coefficient of x squared is greater than 1. So let's say we had 9x squared minus 1, okay, and it shouldn't bother you, okay, it's just like the others that we've been doing, where you work on the obvious ends of this. Of course, this is only 2 terms. There is a minus sign, so I'm thinking, oh, maybe this is that special one where I have a difference of squares. So is 9x squared a perfect square? Obviously the x squared is, and the 9 also is, so together they're a perfect square. So I'm really hoping, and I'm expecting, this to be 3x plus 1 and 3x minus 1. So those conjugates, right, where one has a plus sign and one has a minus sign between the terms. Okay, so that coefficient greater than 1 shouldn't be a problem. You can also see a coefficient greater than 1 in a general trinomial. So say you had something like 6x squared plus 7x plus 1. Okay, so new question. We draw a line there. And once you factor this, and you say, oh, I don't know what to do with the 6, that's going to bother me. And I agree, the 6 is a little bit of trouble. So let's start on the other end, okay? The more obvious end is the 1. It's only one choice you have for how to make 1 when you multiply two things together. At least for us, we're only doing whole numbers, okay? We're not doing fractions here. I'm not doing radicals. So let's call this 1 and 1. Has to be. And I know, of course, plus and plus. I haven't really done a lot of the subtraction problems yet, but I suspect you're good at that too. But I want to talk about this 6x squared in the front. You know it has to be x and x, right? But how do you going to make the 6? You have choices. So you're going to guess and test with how to make the 6. So obviously if I put a 3 and a 2 here, those numbers add up to 2 and 3, 5, okay? So that's not going to work. So obviously I'm going to try the 6 and the 1, and that gives me a 1 for this term, and then those make the 6, and together they add up to make this middle term 7x. So there's my answer, 6x plus 1 and 1x plus 1.